The next big experimental result that revealed the necessity of quantum mechanics is the photoelectric effect. In the photoelectric effect, light strikes the surface of a material, and it may eject electrons from that material. Solar cells also operate as a form of the photoelectric effect, as when light strikes the solar cell, it produces a current if the energy of the photon is large enough. A schematic of the photoelectric effect is shown here, and light strikes a surface of metal, and electrons may be ejected from that surface. The ejected electrons can be manipulated with an electric field using a battery, and basically using this electric field, we can measure the kinetic energy of the electrons that are emitted. We can also measure the current, so how many electrons are ejected from the surface. So on the next page, we'll have a link to a FET that allows you to mess around with this simulation. The key idea about the photoelectric effect is that there is a threshold for the energy of the photon. That means that the surface has a work function, which is the energy required to remove an electron from the surface. In atoms and molecules, this is called the ionization energy, but the idea is the same. If the photon has enough energy, if the photon has enough energy to eject the electron, then electrons will be emitted, and if the photon energy is less than the work function, then no electrons will be emitted. On the other hand, the intensity, so how bright or how intense the light is, does not affect whether the light is emitted or not. If you make the light brighter, more electrons will be emitted if you are above the energy threshold, but the kinetic energy of the ejected electrons will remain the same. So here we can see the graph that shows the kinetic energy of the electrons as a function of the frequency of the photons. Notice the energy of the photon is proportional to the frequency. So we see that there is a threshold, a frequency below which no electrons are produced. Then once that threshold is met, the kinetic energy of the electrons increase with the increase in the photon energy. So if we go from visible light to ultraviolet light, the kinetic energy of the electrons increases. So in the questions you have for picking the right graphs, you want a graph where the photon energy is related to the kinetic energy of the electrons, and that they start at a threshold, not at an energy of 0. We can work out the kinetic energy of the electrons by using the conservation of energy. The energy of the photon is used both to ionize the surface, overcoming the work function of the surface, and the remaining energy is put into the kinetic energy of the electron. So the photon energy is equal to the work function plus the kinetic energy of the electron. That means in the following question, we can give you 2 of the 3, and you can solve for the third. I should note that in my research we often use this method, so studying the electronic structure of nanoparticles and clusters in the gas phase. Then we hit them with UV light, and by measuring the kinetic energy, we can identify the binding energy of the electrons in the particle if we know the energy of the photon. This offers a method for analyzing the electronic structure of particles if you can get them into the gas phase. Alright, so that's it for today's class. On Tuesday we'll run a last set of classes, and Thursday we'll have a quiz and a review. Good luck, and take care of yourselves.